You may remember from chapter 14 that alcohols can be oxidized to aldehydes or ketones depending on whether that alcohol is primary or secondary respectively. And then aldehydes can further be oxidized to carboxylic acids. So remember when we're talking about oxidizing or something getting oxidized in organic chemistry, it means we're increasing the number of carbon-oxygen bonds or decreasing the number of carbon-hydrogen bonds. So we look at an aldehyde, and if we treat it with an oxidizing agent, we get a carboxylic acid. So we increase the number of carbon-oxygen bonds, decrease the carbon-hydrogen bonds, considered oxidized. And what makes the aldehyde reactive is this hydrogen here on the carbonyl carbon is pretty reactive. And ketones don't have that reactive hydrogen, so they do not get oxidized. So when we add an oxidizing agent to an aldehyde, we'll get a carboxylic acid, whereas a ketone, we will not see that same reaction. So because ketones are not easily oxidized, we can treat solutions of unknown compounds with mild oxidizing agents, and if we see a reaction, then we can assume that an aldehyde is present. So one of these mild oxidizing reagents is known as Tollen's reagent, and that consists of a solution that has silver ion in aqueous ammonia, and it's really very beautiful. So when the silver gets reduced, which is what an oxidizing agent does, it gets reduced, the silver ion turns to silver metal and it makes a silver mirror on the flask. So it's very, very beautiful. It's not very sustainable and not easy to clean up. That's why we don't do it in lab, but it is very beautiful. So Tollen's test is one way to test for an aldehyde. If we add this Tollen's reagent, which is actually colorless, to an aldehyde, the aldehyde gets oxidized, the silver gets reduced, and we see that silver metal. This would not happen for a ketone. So Tollen's reagent, reacts with an aldehyde but will not react with a ketone. And a more sustainable test is Benedict's reagent. And this has a copper 2 ion, which is characteristically blue, and it is a mild oxidizing agent. It will get reduced to this brick-colored copper 1 oxide in the presence of an aldehyde. And it shouldn't react in the presence of a ketone. Now, sometimes it can be a little problematic, but in the lab that you're going to do this week, you will see a clear difference between a aldehyde and a ketone reacting with Benedict's reagent. So Benedict's reagent will react with an aldehyde, it will get reduced, and the aldehyde will get oxidized, and it should not react with a ketone. And at one time, Benedict's test was used as a test for sugars in urine, just a fun fact. But what you'll be asked to determine is whether a certain molecule will react with Benedict's reagent or not. So if it's an aldehyde, it will react with it, and if it's a ketone, it will not.